All right, when we look at communities, we're also going to look at some of the important species that go in there. So we're going to look at some different terms that are used, and this one is newer, but we call them foundation species. We always knew about them. I just don't think we labeled them. So here we go. Foundation species is one that builds a community. There's just a lot of them. And so they make the backbone of some community. So here we have on the top left, this would be the plant would be creosote. And kind of hard to tell, but right here up in the front left, that's a creosote, 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 creosote. As a population, if you fly up and over the desert, what you're going to find is creosote is in both our local deserts. And also kind of interesting is that they have a uniform distribution for the most part. If you're flying up and over, they're pretty much evenly spaced. They're all fighting for water, and that's the key. And they're putting out chemicals to kind of keep other plants from growing around them. And so we really get a fairly uniform look to our local deserts in places. These flat areas. So if you ever drive out the 10, you'll start to see a creosote pop up on the other side of the mountain range. Actually, after you, I don't know if you drive out there, but after you pass Morongo, you'll start seeing it. And then on the bottom is giant kelp. That would be another foundation species. And then on the right was a foundation species that has a story. This is the American chestnut. And what happened is we brought in another chestnut, and it brought a blight, a fungus, and this species almost disappeared. And so what used to be these big chestnut forests died off, and it's not probably as big a terrible a story as it sounds, because the other species, there was enough biodiversity there that the other species kind of filled in. There's oaks and maples and things. And no real big animals like birds or mammals seem to be affected. They've done studies, and but there were a bunch of moths, I forget how many, 9, something like that, that actually disappeared because they were very specific to this tree. So there's a story showing, but a foundation species then would be kind of what makes up that area. Coastal sage scrub is its foundation plant, which is on the Mount Sac Hill, would be coastal sage brush. That is the plant that makes up, would be the foundation species for coastal sage scrub. So just to give you an idea. So a newer term, always knew about it, called a foundation species. There's also ecosystem engineers. There are species that kind of set up areas for others, and the best case scenario for this, or the best example, would be the beaver. Beavers are change the environment, and so what happens is they go in and they dam up rivers, they slow down streams and rivers, and that actually causes huge habitats for other species. So these guys are essential for certain species to be there to set up these habitats. So ecosystem engineers, again, another term they're using, but I want you to key into that. And the next one is a keystone species, and this is a picture of our local tide pools, and what you're seeing there is the keystone species, and that is the ochre sea star. And these guys are the ones that are managing and keeping biodiversity. Unfortunately, there has been a virus, we believe, that has been a wasting virus that has been killing these things. And so the numbers have dropped drastically, and we're seeing a huge difference and change in our local tide pools. The good news, I've been taking Bio 2 classes out there for over 20 years, is we are starting just to see a comeback in the sea stars. They were always there, and they, last 7, 8 years, they've been disappearing, and sometimes we don't even find one. But now they are starting to show back up. We're getting lucky enough to find some occasionally. So keystone species. Keystone comes from the idea of stonemasonry. where you actually have a keystone, a important stone that holds those stone bridges together, or stone arches in buildings. And the masons would actually keep that a secret on how to do it, and you would apprentice with a stone mason, and they would eventually tell you the secret of the keystone. So we've stolen that term because basically, if you pull out this keystone, your community collapses. And here again, this was done by Castro over Cal Poly, but Piaster is the sea star. And over the years, what they did was, with the Piaster there, the number of different species present, and if you removed them, you can see it drop down to 1 or 2. And so again, this predator, which is on the top, of the food trophic levels, is actually increasing species. And the idea behind this is that not any one single species can then explode and take over. Because what happens is that keystone predator or species tends to attack whatever there's most of, and it keeps their numbers down so other species can survive. In walnut, the keystone species is the coyote. And again, it keeps them down. Predation controls, community organization, also called the trophic cascade model. It is what we call a top-down model. In other words, the predator is managing this from the top. Coyotes do take pets. I don't remember if I've discussed this with this class or not, but Walnut had an issue where their pets, dogs and cats, get taken. And of course, they get upset. Fluffy has died, and you call City Hall, and they release. What they ended up doing is killing all the coyotes, and by doing that, your pets, I guess, survive. But what happened is 4 to 5 years later, they got same phone calls from the same people, but it wasn't for coyote issues, it was rat issues. And hey, we got rats and mice, squirrels, you got to do something. And again, what happened is the diversity of walnut went down because the coyote was removed. Well, walnut then stopped trapping the coyotes and killing them, and the coyotes moved back in. The rat and population went back down. Things balanced themselves again. Foxes came back up, certain birds came back. Life was good, except for Fluffy 2 is now a target. So Fluffy 2 dies, more phone calls. And unfortunately, just recently, a few years ago, Walnut went back to trapping, and the biologists at Mount Sac, we've actually went to the meetings and told them this is asinine. You're trying to control something that can't be controlled like this. It's really, you want control, it's education. People, bring in your pets, don't leave them outside, don't feed coyotes, don't leave food outside for coyotes to get, don't give them resources and they'll leave. But why listen to a biologist? All right, so here's another famous one, is the orca and sea otters trying to balance things out, and so looking at kelp density, and there's been all kinds of issues. Sea otters, what happened with sea otters is sad. Seals were, the orcas were actually eating mostly seals. When the seal population dropped, they flipped to otters. And the problem is sea urchins actually eat the kelp. And so we have seen over time, when the sea otter population dives, the sea urchin population goes up, and then the kelp suffers. And so definitely an issue, so all we're trying to show you is just by removing a single species, it could be extremely alarming. And here we're actually adding a predator that wasn't a predator on this species anyway before. The other way to look at it is bottom-up model. And the bottom-up model is where it's not a predator from the top that's attacking, it's actually a plant from below. And the absence of some plant is causing an issue. And really, more than the plant, it's usually some nutrient that's in the ground that the plant is using. So this is newer. Everybody assumed it was the predators on top. that did this, but there are some grasslands and things that we realize that it's actually the plant that's probably has more influence than the predator from a top. So we just want to let you know that both of these do exist. And so here's a good example of both. Yeah, so just take a look at that. All right, we are done with this one.